In this video, we are going to do a Bernoulli probabilities example in which we end up with a range of values that we need to consider, and we'll do this through casework. So the example says a multiple choice exam has 25 questions, each with 3 answer choices. Raina guesses answers randomly. What's the probability that she gets at least 80% of the questions correct? Okay, so what makes this a Bernoulli question is the fact that there are 2 outcomes for each question. Either they get a question correct or they get a question incorrect. So if we write the probability of getting a question correct, because each question has 3 answer choices and she's guessing them randomly, she has a 1/3 chance of getting any question correct. And that's going to be our probability of a success, which we'll label as P. And it's a success here because the question is asking about getting questions correct. So that's how I know correct corresponds to a success. And if I were to write the probability, the probability that she gets a question incorrect, well, that would be 2/3. She has a 2/3 chance of getting any question wrong. And this we would label with a Q. That's our probability of a failure here. And we also need to know, well, how many questions does she have to get right to get at least 80% correct? So 80% correct, if I take 25 questions and I multiply that by 80%, if I convert that to a decimal, I'll get 0.8. And if we multiply these, we get 20. So this means that she would need to get at least 20 questions correct in order to get at least 80% correct, like the question is asking. All right, so at this point, if we try to write down the probability that she gets at least 20 correct, and when we say at least 20 correct, this is out of 25 total questions. There are several cases that we need to consider, because at least 20 correct could mean she gets exactly 20 correct. Maybe she gets 21 correct or 22 correct. So we would need to find the probability that she gets 20 correct, and then add that to the probability that she gets 21 correct, and then add that to the probability of getting 22 correct. And hopefully you see where this is going. We got to keep adding these cases. So probability of 23 correct, until I finally get to the probability of 25 correct. So probability of 24 correct. And then finally, probability of 25, all 25 correct. Alrighty, so now with each of these probabilities, we can use our formula for Bernoulli probabilities. So for example, for the probability of getting exactly 20 correct, we got to first count the number of ways that we could get 20 questions correct out of the total 25. And there we use a combination. We got to choose 20 of the questions to get correct out of the total 25 problems on the test. And then we'll multiply that by the probability of each outcome. So a success probability is 1/3 here of getting a question correct. So we need a 1/3 for every single question we got right. And there's 20 of those questions we got right. So 1/3 to the 20 power. So this 20 is representing the number we get right. So the number right. And then we have to multiply this by the number of questions that we don't get right, and those probabilities. So there's a 2/3 chance for every single question we get wrong. And if we got 20 correct, that means we got 5 questions wrong. So we'll need to multiply 2/3 times itself 5 times. That gives us 2/3 to the 5. So the 5 here represents the number that we get wrong. Okay, so for example, the probability of getting 20 correct, that is matching up with this expression right here. And we can see why this is going to be a little bit long. I got to do something like this for each of these probabilities. So the next probability of getting 21 correct, let's see, there would be 25, choose 21 ways to get 21 problems correct. And then the probability for correct answer choices would be 1/3 to the 21 power, because 21 problems need to be right. For wrong questions, there's a 2/3 probability, and 4 questions would be incorrect. Let's move on to probability of 22 correct. We'd have 25, choose 22, and then times the probability of getting something right, 1/3. We got to get 22 problems right, and then a 2/3 chance of getting a question wrong, and we got to get 3 questions incorrect. Okay, now keep going. So plus for 23 correct would be 25, choose 23, and I would have 1/3 to the 23, because 23 problems are right, and then times 2/3 to the 2. We'd have to get 2 problems wrong. And then 24 correct would be 25, choose 24 ways. That's how many ways we could get 24 problems right, and multiply that by 1/3 to the 24, and then times 2/3 to the 1. We'd have to get 1 problem wrong. And then finally, for all 25 problems right, we'd have 25, choose 25. We would have 1/3 to the 25. That's the probability of any outcome of getting 25 problems all right. But I don't have to write any of these 2/3, because if we got 25 problems correct, that means we got none wrong. So we don't even need to bother writing something for the ones that we got wrong. Okay, now we got to work out what this thing is. So here is where using a calculator can help out. So I'm going to show you how to enter something like this into an online calculator called Wolfram Alpha, and then I'll write down what we get at the end. All right, so I'm going to use the online calculator Wolfram Alpha to evaluate the expression that we had. So going back to the very first term, I need to enter this term. And the nice thing about Wolfram Alpha is I can enter in combinations. So I can do stuff like 25, choose, 20? And it'll already preview the value. So the next term was 1/3 to the 20th, and then times 2/3 to the 5th. So that was my first term. And then I'll get plus, and the terms after that are really similar, so I'll start to copy paste. And then it's 25, choose 21. This x1, it becomes 21, and this becomes a 4. I'll copy paste again. I change this to a 22. This becomes a 22. This exponent needs to become a 3. Got to do this a couple more times. Now I make this a 23, make this a 23, make this a 2. We'll copy it again. Now I need a 24 this time. 24 here, a 1 here, and then 1 last time, where I make this a 25, choose 25, make this a 25. And on the last one, we don't need to enter in this last term at all, because there were no questions that we got wrong. So if we enter this in, it's actually previewing it for us already, but let me just enter it so we can see what we get. Alrighty, so it's worked out what this expression is. It's always a good idea after it does it to look at the input. This is what Wolfram Alpha thinks I meant to enter in, and to check, is this the thing? Is this the same as what I actually had when I was doing my work? And it is. But if it wasn't, it's a good idea to check parentheses. Sometimes it's helpful to leave an extra space between plus signs, just so it doesn't get confused there. But notice that what we have is this decimal, 2.26 something something something, and then times 10 to the negative 6 power. So let's write that down. So writing that down, we get, 2.26, if I round it to 3 decimal places, 9, times 10 to the negative 6. And that is our probability. If I wanted to get a feel for, how big is this number actually? When I have a negative exponent like this, multiplying by 10 to a negative power, that's going to move the decimal point to the left. In this case, 6 spots. So I would do 2, 2, 6, 9, and then it got moved over 1 spot, and then I need 5 more spots. So I'll put a 0, 0, the second one, third one, fourth one, fifth one. and it would be like that. So this is a really small number. So it's a super small probability that something like this happens.